Hi, everybody. We're ready to start lecture 2, but we have some guests from the tutoring center here on campus. Tyler and Ainsley are here to tell you about it.
So thank you for letting me come in today. But my name is Tyler. I'm the Math Lab coordinator. So what the Math Lab is it's just really free tutoring for you guys. You're welcome to come in with any math class, whether it's this one or any other math classes when I start working with you. And so specifically for this class, while I do know a lot of the material, I wouldn't say all of it, but I do know most of it. We also have some tutors who have taken this class before with this instructor. So you guys are more than welcome to come in. Tutors like Ainsley will know exactly what you guys are looking for on your homeworks. So that'll be perfect for you guys to come in and talk to us. Our schedule is a little bit weird, which is why we're handing out those bookmarks right now. If you scan that QR code, it'll take you to our website and you can see our schedule on there. But in general, we're here Tuesdays and Wednesdays from 8 a.m. to 6. Yeah, I got you. Keep going. But we're here Tuesdays, Wednesdays, 8 a.m. to 6 p.m. And then I also have tutors Mondays from 2 to 6, and then Thursdays from 9 to 2. So, like I said, it's a lot to remember. So that's why I give you guys the QR codes. You can scan them. The schedule should be on there. So. But we can help with any math or math related class. So I help out with the welding students here on campus as well, the soil science students. So as long as there's some sort of math component, whether it's this class or another, you guys are welcome to come in. It's a great spot to just come in and do homework. We have laptops you guys can borrow. So that if you don't have your own, you're welcome to work on it with us that way. But that's just here on this campus. We're located upstairs in building A in the library. So have you guys all been to the library before? What's required now? So if you go up the stairs in building A, and we'll just keep walking straight, and we'll enter the library, and then we're in like a fishbowl looking room, right in the middle, surrounded by glass. Really hard to miss us because I cannot physically hide in there. So it's sweet. And I'm also available online. So if for some reason you guys aren't able to make it throughout the week, I do online appointments as well through academia. Your instructor also does some appointments with me, so it's very possible you get one or the other when you're scheduling the appointments. So yeah.
Do you guys still have a laptop they can use while they're in there?
Yes, we do still have laptops that can be used. Excuse me. Do you guys have any questions for me? Awesome. Well, thank you for the time.
Thank you.
And you guys, thanks.
Generally, students that do the tutoring and stuff like that are, if you have questions, ask, and your grade will go up. It is not a waste of time. You learn by asking questions. And if you don't want to ask them in class, you got to ask them somewhere. And that's a low pressure environment to do it. Let me share screen and we will proceed with lecture. We will proceed with the lecture. So we're going to cover 2 sections today. We're looking at R2 and R3. So let's see. Since I scan them, I like to put the lecture date on them, so I keep track of where we're at. R2 is on inequalities. And as you'll see, R3 is on absolute values. These topics are definitely connected. It's got the word equal in it. For R2, it's got the word equal, but the N means not. So not equal. Equations that are not equal. This gets you your less than and less than or equal to. This is the less than category. And your greater or greater than or equal to category. We have a couple things, categories this. There's called the unbounded inequalities. And in this region, we have a one-sided thing. Here, X is my variable. And A is a number. We have a less than or equal to X, a less than X. We'll make B a number 2. We'll have that going the other way. X is greater than B. X is greater than or equal to B. So something you can treat this as the inequality very much acts like a predator. It always wants the bigger meal. Put a little teeth on that sumbitch. So if I want to rewrite this with X on the left and A on the right, the teeth still need to be going after X. So I'll make the graph that way. We can always do this at any point, switch them around. So what would this end up being? It'll be X. This is not less than, greater than. So what's going on with this? On a number line, maybe I'll call this 1, and we'll use blue for 2. We want numbers that are bigger than A. So like A plus 1 is bigger than A. Like if A equals 2, then 3 is bigger than 2. That kind of makes sense. So we're looking for numbers to the right of it. And I'm going to put a solid point like that. The textbooks and a lot of programs will do this. Use a bracket. For A less than X or X is greater than A, we're looking for numbers that are bigger than A, same thing, but we don't have the equal portion anymore, so we put an empty circle and point in the same direction. And if they do it without using like circles like that, they use a bracket. Instead, they do a parentheses. So depending on if you've got the inequality set up with X on the left, the inequality acts like an arrowhead. So like, great, arrow pointing to the right. Yeah.
Did you say the ones with the solid dots are equal to or not equal to?
Equal to. So solid points or brackets go with the greater than or equal to or the less than or equal to signs. And the hollow point or open point And parentheses. These go with greater than or less than. And when we do interval notation, the infinities, negative infinity and positive infinity. I'm going to get to those in just a sec. In fact, I'll discuss interval notation here, and then I'll go up and rewrite it up above for the ones we have above. Interval notation. Interval means range of numbers. Interval is a range. So we're writing like the boundaries of the range. We put the lowest number first, the highest number second, and then we have symbols over here. We can either have a parentheses or a bracket. And over here, I'll even deliberately change the order. We do bracket or parentheses. And it might be best to just see how it is. So I'm going to bring those pictures back down. If you've got the number line written out, it is so easy. Put your pen on the left, move it to the right until you start hitting your line. Here, I started hitting the line at A. And I keep going, and I have an arrow, so the arrow doesn't stop. It went all the way up to infinity. A had a solid point, it gets a bracket. Infinities are always parentheses. Down here, we had the same thing. It started at A, and it kept going to infinity. But this time it's a hollow point, which means we use parentheses. So a way of looking at this hollow point idea is up to, but not including the number. Everyone ready? So these are called unbounded because all of these end up having infinity signs in them. They all have arrows on them that don't end. There's another category called the bounded inequalities. Maybe I should give you guys a little practice on those inequalities real quick. Just make sure you're on the right page. So do the graph and interval notation. or x is less or greater than 3. We'll do x is greater than or equal to -1. X is less than -2. And x is less than or equal to 4. If you get these down, everything else is after this gets a little bit easier. This should be review. Like you should know, remember this already from previous classes, or have seen it before sometime in your life. It may have been a really, really long time. And there's nothing wrong with that. I came back to COS when I was, let's see, low 30s. I was in my early 30s. And I did not have a degree before that. Came back to get my degree and started in this very class. Well, the old equivalent of it. I started in intermediate algebra when I started here. And I worked my way up through the ranks, and here I am now. So age doesn't need to stop you. In fact, older students tend to know what the fuck they want to do. And they know they don't want to do whatever the hell they were doing before, so they're willing to put in the work to pass the class. I told my D&D friends this weekend about the student that told me the best way to dispose of a body was in an acid pit at UC Davis. Yes, you came up in class in my free time. And their first question was, how the hell did it? Why does she know that? That was my same first question. And you told me.
Yeah, because like it just started like when I was doing my internship, like it was a new thing, so everybody was excited. It's obviously not for dead bodies, you know.
Sure.
It
That's,
was, we work right next to the necropsy lab, so that's how they got rid of all the cows, the horses, and all the stuff.
for dead bodies,
Yes.
just not human bodies.
Not yet.
And they could identify it as a animal,
Right.
right? At least that's what the paperwork would say.
All right, I'm gonna start drawing these. Really, when you do a number line like on the screen on ALEKS, it'll give you the whole thing. You really only need to put 0 down and maybe the number that you're talking about. Any other like marks that you write, as long as you got those correct in the right order correctly, the rest is long. X greater than 3 is, how do I draw this? Circle, filled or open?
Okay.
Open,
So,
and to the right, okay. And how would I write this in interval notation?
parentheses.
We need to have the infinity there. 3, infinity onward. If it helps you, put negative infinity at the end of the rest. For those of you that are unfamiliar with infinity, other than to infinity and beyond, good old Buzz Lightyear, Infinity just means the highest number possible is a generic way of saying it, but there really is no highest number possible. Because no matter how big of a number you fucking give me, even if you make up some fucking like quadrazillion or some bullshit like that, I can always say like quadrazillion plus one. So there's always a bigger number. So infinity is just like the idea of the most extreme value. So there's no end to it. And we use positive and negative to indicate whether they are negative numbers or positive numbers. All right, let's go with x is greater than or equal to -1. -1 is to the left of 0. How should I do this graph? Close circle?
Going to the.
It's going to the right. I love that you pointed, because from my perspective, you're pointing the wrong direction. But I know if I turn and look at it the way you're pointing to the right. To me, it looks like you're pointing to the left. And when we do it in interval notation, we just put our pin on it. We start at -1. We keep going until we hit infinity. Solid points get brackets, infinities get parentheses. Draw my lines real quick, so I'm not picking up the black pen again. What should we have here?
Focus circle. It's greater, or x is less than -2, so it's going to the left.
Yes. What is the interval notation?
Parentheses.
-2. Infinity.
Okay, so that's a good question. I heard -2, negative infinity. But the number that if I went left to right, the first number I see would be negative infinity, -2. This one is actually not correct. You want them from low to high. Don't forget that part. I was talking with the people at ALEKS today, going over some stuff. Some students, very, very few of you, spent like 5 minutes or less on the initial knowledge check, and you have a metric fuck ton of homework. Rather than the students that did it, and a lot of students didn't even have homework for R1 because they remembered enough of it. If you were one of those that didn't follow it and did just 5 minutes, and you want to redo the initial knowledge check now that you've done homework for like a week, and you're just like, God damn, that's a lot. Email me and I can reassign you an initial knowledge check that you can take again, and it will reset that shit. Okay. But I don't want to just give it out to everyone that has less time than that, because some people really just want to do all the problems, as much work as they can. So it's up to you. All right, what about this one?
Solid circle
Solid circle
to the left,
to the left.
parentheses, infinity, 4 bracket.
Close.
Damn it.
You're really close, Jimmy. You're missing just one thing.
What did I miss?
Negative.
Oh, negative. That's right. My bad.
This is the spot to make a mistake. The homework is the spot to make the mistakes. Mistakes are great. Mistakes are learning opportunities. Do not put yourself down. Some people beat themselves up, even if it's only in their head. Making a mistake, you should make mistakes. If you're not making mistakes in this class, you probably don't belong in here. That includes me. I make mistakes all the goddamn time. You'll see me. I'll tell you 4 + 1 = 6. I get thinking too fast and I just fuck up. All right, so those are my unbounded inequalities, then we have our bounded. This means there's like no infinities. The interval has a start and a stop. And set up 4 different sets here. 4 different regions. I have a solid point going up to an empty point. I could have an empty point going up to an empty point. I could have a solid point going to a solid point. Or I could have a hollow point going up to a solid point. There are only 4 ways to do that. If we look at the interval notation for this one starts at -10 and goes up to, if this is -5, 1 to the left of it is -6. We have a bracket for the -10, parentheses for the -6. And another way of writing this is -10 is less than or equal to x, which is less than -6. See if you guys can figure out what the rest of these are. I'll write the numbers what they lie underneath them to make this a little bit easier. See if you can do the last 3 line segments. Premise hasn't changed though. I wonder if Ainsley started cussing me out on Messenger yet. Nope. Yeah,
And how you know, less than equal to X means less than equal to 6, right? Greater than 10? Because you're going towards 6.
if I write it the other way, that's a really good question. So if I put the X on the left, this would be X is greater than -10. This is the third way of writing it. X is greater than or equal to -10, and X is less than -6.
Okay, so is the 6 then considered as our X?
I'm sorry, say that again?
Like, okay, so how you said if you put the X on the other side. Where was X in the first place?
It's between the two.
Got it.
So like, if notice I switch these around, I would put -10 here, X here,
Mhm,
and the alligator chases this.
mhm.
I could put the -6 over here and the X over here, and the alligator should still chase the -6.
Oh, okay.
But I wouldn't ever write it as this. This is weird. I wouldn't do that. So I'm gonna actually black that out so no one tries to do that.
Thank you.
This is a third way of doing it. But the and kind of makes a sandwich. So it's doing two regions. I have two requirements. The first requirement is the value's got to be bigger than or equal to -10. And the second requirement is it's got to be less than -6. So there's a lower value and an upper value. There's a cutoff. Usually people write it as the sandwich with the two symbols as well. What about the red with the hollow points? What should I write this as?
Red,
This one right here.
less than, I mean, yeah, it's the less than or greater than or less than.
Yes, it will be strictly those.
Yeah.
But like, what am I putting for like interval notation and
-4 is less than X. And 1 is greater than X.
1 is greater than X? Is another way of saying X is less than 1. It's true. This is awkward. It's hard to picture, believe it or not. 1 is bigger than X, like, okay, what does that mean X is? Normally we would put it the other way. And we'll put that together to make a sandwich.
Tomato.
Yeah, but 1 is like confusing for most people. And generally, if you're writing it down, you're wanting to communicate it with others. Right? Now, I won't mark it wrong if you're like, you do it on the test and you do it all weird. If it's correct, it's correct. What is the interval notation for this? That was this form. Interval notation does do this kind of thing though.
Parentheses -4. Parentheses -1, I mean, common -1 parentheses.
It'll be +1, but parentheses, yeah. Davis looks like he's ready to do one. Davis, right?
Yeah.
Hit me with the blue, Davis.
So blue should be parentheses 3, 5 bracket.
You sound unsure. Are you sure?
No, bracket.
The bracket is actually the correct one.
Got 2 brackets, doesn't it?
It's got 2 brackets. It's a solid point on both sides, so it should be a bracket on both sides. How would I write this as a sandwich thing?
3 is less than or equal to X, which is less than or equal to 5.
Yep. So one way of looking at it is if you write it in this form like this thing has like part of a bracket on it. If you look at the equal sign, it's part of a bracket. And if it doesn't have the equal sign, just looks like a parentheses that's been made into a corner. I don't know if that's helpful, but everybody remembers shit different ways, right? All right, last category. 7-10 split. What do we got going on here? That's some bowling shit right there for you.
It sounds like school and shit.
Parentheses 7, comma 10 bracket.
Are you good with that? Is that your final answer?
Yes.
That's correct. How would I write it in sandwich notation?
7 is less than x less than or equal to 10.
Looks good to me. Okay, so those are the bounded and unbounded. Those are all the different ways we could set these up. In a little bit, you'll see the OR principle, but let's work with doing some algebra with this shit first. Because like we didn't actually do anything but just like state what the regions were. So what if instead I had 4x plus 2 is less than -5? And I want to end up with interval notation and graph.
Two on both sides.
We can do this. So the principles of the algebra still hold. Treat it like an equal sign. For algebra, but with one exception. Well, with 2 exceptions. And I'm going to list the exceptions and they'll show up. None of them show up in this one, but, well, I can force one to show up in this one. If we multiply or divide by a negative number, lift the inequality direction. Maybe the direction of the inequality is a better way of saying that. I'm going to give you an example without variables in it. So you'd be like, yeah, that should make sense. If I start off with -3 is less than 2 and multiply both sides by -2. So -3 times -2 would give me what on the left?
Positive 6.
Give me a +6 over here. And what would be on the right? -4. Which way should the alligator be going? Towards the 6. So we multiplied by a negative, we flipped the direction of the inequality. It went from that to that. That's what I mean by it. And seeing it with numbers works, but this also holds true if there's a variable here. Because the variable just represents a placeholder. The other time you've already seen. We move sides or switch sides without any algebra. Without any operations, I should say. If we had 5 greater than x, I put the x on the left and the 5 on the right. sign flips. So those are the 2 times the sign will flip. So let's go back up to that 4x plus 2 is less than -5. I said treat it like an equal sign. Do that. I strongly recommend against putting an equal sign there. Because some students will put the equal sign there to feel comfortable with what they're doing, and they forget to put it back. And if you multiply or divide by a negative, you're going to lose track of flipping. So just pretend it's an equal sign and work with it. So you were correct. We are going to subtract 2 from both sides. What's your name?
You?
Keith.
Yeah.
The inequality symbol comes down. 4x, and then -5 and -2 is -7. We divide by 4 or multiply by 1/4. Both work. X is less than -7/4. Which is -1.75. If it helps you put it on number line. Or -1 3/4. I switch it back and forth between writing fractions with a flat bar or this diagonal bar. I'm not consistent. I do both ways. They show up both ways all the time. What is my interval notation here? This is what we're looking for. And what's my graph look like?
Open circle. To the left.
If that's correct. If you're unsure, if you're ever not sure of yourself, pick values on either side. On the left side, I've got 0, or on the right side, I got 0. Over here, pick something fucking ridiculous, like -100. And then look at both of those. Go is -100, use this symbol here, -100 less than -7/4, or is 0 less than -7/4? Only one of those is true. That one's true, so we're going to shade in the direction of the -100. So you can always substitute in values to like help you pick. What is the interval notation here?
Parentheses, negative infinity. -7/4, parentheses.
Yep.
So that's is that an unbound?
This is unbounded, yes. Ready for another? -2 is less than -x. I'm sorry, -2 minus x is less than 7. There are actually two ways to go about doing this. When the way we learn is to move the values. So here I would add 2 to both sides. And I have negative x is less than 9. And then I could either multiply or divide by -1 to get rid of the negative. And in the process of doing so, the inequality flips. A lot of students forget this negative. And shit goes downhill really quickly. You do have an alternate option. Let me just set it the same way. When the variables, I only really do this when the variable is negative. Instead of moving the number, I can move the variable by adding x to both sides. So I have -2 is less than 7 plus x. Now, when I subtract 7 from both sides, I get -9 is less than x. And we know when we do the old flipperoo sides, we get that. It's pretty much the same amount of work. But notice you can't accidentally forget there's a negative here, because x is positive now. Over here it's negative, and sometimes students just don't bring the negative sign down. Whether you made the first negative too small and you didn't really notice it, whatever the reason, sometimes students don't bring the negative down and then the answer gets wrong. So we have x is greater than -9. I'll circle pointing to the right. And -9 to positive infinity, both with parentheses. Okay, looks ugly, right? Why? Fractions, right? Fractions make it ugly. Fuck fractions, let's get rid of them. To get rid of it, we gotta multiply through by a number that will wipe out the bottom. So we gotta multiply through by a number that will wipe out the bottom. The easiest way to do that is multiply by the least common denominator, the LCD. So I can factor the 6, the 3, and the 4. Just to find out what an LCD is. 6 is 2 times 3. 3 is already factored. And 4 is 2 times 2. I like to make a little table with columns, and the numbers in a column have to stay the same. And the LCD will be 1 from each column. 2 times 3 times 2 is 12. So we're gonna multiply that one by 12, multiply that one by 12, multiply that one by 12, and multiply that one by 12. And for the ones with a fraction, I strongly recommend you put a little fraction in. Now, you can multiply this out and say that's 60 over 6, which is 10. The other way to do it is break down 12 into what it is. 12 is 2 times 6 over 1 times 5 over 6. Cancel out the 6's, and we're left with 2 times 5 is 10. This is actually, although it looks like more work, for like large numbers, when you don't have a calculator, this tends to be easier than multiplying big ass numbers and then trying to divide big ass numbers. So here, this is 3 times 4, and the 3's will cancel. I have a 10x for the first one. The 3's will cancel, and I have 2 times 4 left is 8. For here, with the 3 4's, if I treat 12 as 3 times 4, the 4's cancel, and I'm left with 3 times 3 is 9x. And 2 times 12 is 24. Fraction work is the pain in the ass right there. But now we don't have fractions anymore. So we got rid of it all at once, and then now it's gone for the rest. Believe it or not, this is probably the easier way of doing it. Working with fractions the whole way. You guys should have fractions at every step and you can do it, but it's a pain in the ass. Now we can move all our x's to one side and move all of our constants or numbers to the other. And on the left side, 10x minus 9x is x. And the 8's cancel. On the right, the 9x's cancel. And 24 plus 8 is 32. Yeah.
So then, as long as there are like terms, no matter how complex, you can just add or subtract. Multiplication is just kind of not necessary.
As long as they are like terms, so it's the same variable, same exponent,
Yeah.
you can add or subtract as long as you do so equally to both sides of an inequality. Just like you could with an equality. It's mostly like picturing it as scales, balance scales. If you add shit or take shit off one side, you gotta do the same thing on the other side, the scales become unequal. That is probably an old reference. I don't even know that they use the fucking scales anymore. Let's take a 5-minute break. I realize it's 4:05. Let me hit pause. Okay, quick note before I continue on ALEKS, the homework cutoff dates. The way it works is like when R1 is finished being due and the R2 through R5 assignment starts, it will not let you go back to work on R1 until you've done all of the work for R2 through R5. And then it'll allow you to go back, but when you work on the old stuff, it won't give you credit for it for part of the class. Because remember when I showed ALEKS to you guys, let's see if I can load it up and point it out real quick. Assignments. A lot of you you'll get points for doing this and then all these assignments here. But at the end of the semester, there's a cumulative learning goal, which is what you've learned. And so there's credit for that as well. So if you go back and work on old assignments that you like, if you fell behind, going back will still adjust this because this is still worth credit for your grade. But like if you didn't do anything for R1 and you tried to start on like Friday when it's closed, you would get 0 points up here. It would only count towards the cumulative pie down below. I am probably, just because not everyone knew that, some people are a little bit slackers in the first week, probably going to extend the R1 to make it so you can access it. I have to change the dates for R2 when I do it, because they have to be aligned, because for some reason I can't do overlapping dates in here. But just keep in mind, normally you have a week to do the assignments. Please do them in that week, because after that, it won't give you credit. All right,
Professor Jones,
that's me all day long.
head out. Do you mind sending or reopening that ALEKS for me, please?
The initial
Yes,
knowledge check.
Yeah.
Send me a message, because I'm not going to do it right now, but send me a message and I'll take care of it.
Cool. Thank you. See you Thursday.
Okay.
Bye.
Bye. All right. Back to the topics at hand. We're going to do a little bit more on R2 because there's a little bit more stuff to do. The absolute value is a little bit shorter. We also have our and or topics in the inequalities. So like 3x plus 7 is greater than -2. Or 3x plus 7 is less than -4. For the or problems, the solution has to be in one of them. Just one to count. You'll see what I mean by that as we work this out. So we solve the problem separately. Here I will subtract 7. And I'll divide by 3. I get x is greater than -3. Or same process over here, subtract 7. 3x is less than -11. Divide by 3. X is less than -11/3, which is -3 2/3. X is greater than -3. I'm going to put a circle on -3 and go to the right. X is less than -3 2/3 is right about there, -3 2/3. And that's to the left. So there's 2 different regions. It can be in either region. It can't obviously be in both. If we say like x is -2, it's only in one region. There's no way to put it in both inequalities. But as long as it's true for one of the inequalities, it works. So if I want to write this in integral notation, Let's do what I did with the pen. I start at the left, which is negative infinity. And I go up to negative 3 2/3, which is a negative 11/3. And these are both parentheses. Because we don't have a equal sign. And then I keep going, and there's no graph between negative 3/3 and negative 3, but it starts up again at negative 3, and it goes all the way to positive infinity. When we have two regions, we put a big fat U between them. The U, which tends to be wider than a regular U, is for union. And it means answer is in either region. Any questions on that? Okay, I do want to point something out because it's always possible to do when you have something the same. Notice that I have 3x plus 7 on both of these. I can try to make a sandwich. Make a sandwich. I hate saying sandwich. I love saying sandwich. But that like makes a lid. Sandwich doesn't have the word and in it. I like having the word and in it. The 3x plus 7 was the same for both of them. You can only really do it when the equations have both. And I gotta keep the symbols pointing the same way. So if I have 3x plus 7, here, the one on the right is pretty straightforward. I got less than negative 4. If I want to put in the negative 2, I got to put it on the left, and the alligator's got to chase the 3x plus 7. And I want to make it very, very clear, I said try. Because many of you will try this at some point. Hopefully it's just on the homework and not the test. Because the homework will just slap that shit down. What is this? This is like a sandwich. These are numbers in the betwiddle. In the betwiddle. The fuck? What happens if I cover that up? I'm effectively saying negative 2 is less than negative 4. Is that true? No. So we can't sandwich. You really kind of want to stick to doing sandwiches when the word and shows up, or is usually the deal breaker. Every once in a while, the equations for the or are in such a way that you could actually end up doing a sandwich, but not really. An or ends up being an overlapping region. It's never a sandwich. The or is never a sandwich. But people forget. So if you try to shove them together, always just cover up the shit in the middle and go, does this shit make sense? If it doesn't make sense, it doesn't work. So don't do that. This is bad juju. That's my way of saying don't fuck that. Let me give you guys one to do real quick. I will punch you a second time when I get home. Whoa. Anything that was just in here? I was trying to do voice to text and I said I will taunt you a second time when I get home. Fucking voice to text for taunt and put touch. And thankfully, the fucking Wi-Fi fucked it up and didn't send it right away. Because I will touch you a second time when I get home. That's gonna get my ass in trouble.
That's incriminating.
That's something I can actually get fired for. I have tenure, it's really hard to fire me, but sexually harassing students is one of them. About 4 years ago, I had a student that smelled like she worked at C's. And it was near the end of the semester, and she brought me a box of candy as like a thank you gift. And she came to my office all the time. It's in class, it's quiet. This is the start of class, and I walk over and I accept it and I give her a hug and say thanks. And she just got off work from C's. And I did not know it, but when you work at C's, you fucking come home smelling like chocolate. So when I went to hug her, my head was right next to her. And I involuntarily. That's what I did. And I even closed my eyes while I did it, because it just smelled so fucking good. And I opened my eyes, and everybody's head was fucking whipped around staring at me. I was like, holy, I'm like, no, she smells like chocolate, I swear. I'm not being concrete. Good times. Danielle, that was Danielle. She's like, yeah, I smell like chocolate, I know I do. She laughed at it, everybody else was like, what the fuck? All right. I went with an and here, I didn't tell you about ands. So and, this is dumb, I meant to give you an or. Fuck it, I gave you an and. And the and criteria, as long as you got to solving them, you're all right till the end. And means both must work. Both must work. So when we have a solution, what we're looking for on the graph, where these lines overlap. So 2x minus 3 is less than or equal to 5. You've added 3 to both sides, and you get 2x is less than or equal to 8. Divide by 2, and you get x is less than or equal to 4. And 3x minus 1 is greater than 11. Add 1 to both sides, and I get 3x is greater than 12. Divide by 3, and I get, oh, this is fucking lame. This is what I get for picking fucking shit.
So is that untrue then, or?
No, okay, so this is a pain in the ass. This is the worst example to lead with. All right, so the left line is like that. And the right line is like that. And there is no overlap. So there is no solution. Fucking worst one to start off with. This is what happens when you randomly pick fucking numbers to try. What if this was an or? Let's make this a learning thing. Let's salvage this. What if this was an OR? Same graph, but now it can be in either region. And wherever this hits, like all the numbers up to 4, including 4, count for the red. And then we don't count 4 for the blue, but we count every number higher than 4 for the blue. This ends up being negative infinity to positive infinity. So it's all numbers work for the OR. We'll do one with an and that's gonna work better. Let's see. Another symbol for all numbers, well, really all real numbers. This semester, we will cover complex numbers, which are not real numbers. Another way that you will see this in books is an R with a double vertical line on the left. This is the symbolic representation for all real numbers. There are other ones with have the double line on the left, like N is natural numbers and Z has a double bar on the cross is complex. Pretty much the only one you really need to worry about is the R. That's the one you see the most. So knowing what this means just negative infinity to infinity. Any number works. Let's see if I do that one. Hopefully I didn't mix it up and fuck this up. We will find out shortly. So the one on the left, we can subtract 9 from both sides. And I have negative x is greater than or equal to negative 2. I divide by negative 1. What do I get? Less than or equal to 2. Remember, we did a negative, so we got to flip. Be mad as shit if I got the same setup over here. Doesn't look like it. Ah, fuck, this is still a no solution.
Question.
Yeah,
So, when we flip the sign, it's always gonna be a negative, correct? Like when we flip it,
if you flip it, yeah, you've multiplied or divided by a negative.
regardless if the x is by itself or with the variable? Like, cause we have 2x on this side.
Whatever you divide, like, the reason why I divided by negative 1 is negative x really means negative 1x, these are the same thing.
Right.
So it's divided by what's in front. You kind of don't want to do the division until you move the number to the other side.
Okay.
Like if I divide by negative 2 here, 9 divided by negative 2 is a fucking fraction. Who wants to work with fractions? I don't. 3 divided by negative 2 is also a fraction. Now we have fractions throughout the problem. So you want to do like multiplying, dividing last. So like the problem only shows up when you,
Okay,
does that make sense?
yeah. Thank you.
Unfortunately, this is another goddamn example where it doesn't work. There is no solution. So let me grab a problem from the fucking textbook that I know works. It's important to see how this actually works, right? Let's do this. So the and. X is greater than or equal to 1 is solid point on the 1 and going to the right. X is less than or equal to 3 is a solid point on the 3. And arrow going to the left. The and is a region of overlap. These overlap between 1 and 3. Both the red and blue line include the 1. There's no hollow point anywhere. So we're going to have a bracket on the 1. And both the red and the blue line include the 3. So we're going to have a bracket on the 3. This is one of those, if I try to rearrange the order, I've got X is less than or equal to 3, and if I put the 1 here, and the alligator's got to keep chasing the X, I could write it like that. If I cover up the X, I still have a true statement. 1 is less than 3. So I can combine them. This is valid. This is a valid combination, valid combo. The sandwich works. One thing you should never have when you do these sandwiches, you can have low, less than or equal to X, less than high, or with the equal sign if you want, or you could have high is greater than X, which is greater than low. These are both valid. Alligator's got to go the same direction, and the high and the low got to be correct. The alligator's got to match with the high and low. Never, ever have shit where the alligators point in opposite directions. Never ever do either of these. It just doesn't make any sense. You have a question? You already have a question, Davis.
Yeah, I'm curious on. I guess I'm curious to see. If there will be a real world example where we use this math to calculate the factor or something.
Let me get into the absolute values,
Okay.
which use this same shit. And there are lots of real world problems. In fact, when you were walking in, that's what we were talking about when you walked in earlier. In the support course. So let's segue, that will segue us into R3, which is absolute values. Which we not like to denote with the absolute value bars. That's what this shit is. Now, if there's a number inside. A lot of this just boils down to make it positive. The absolute value of -2 is the same thing as the absolute value of 2, which is 2. Where absolute value shows up in reality is it represents distance from 0. Or as you'll see in the examples, a specific value. So both of these are exactly 2 steps away. And that's why -2 equals 2. The absolute value of it, and absolute value of +2 equals 2. Okay, you guys ready for more? We haven't done the algebra yet in this section. There's no X in this. Let's add some X's. That's what this class is about, variable. Are you guys tired of X? You want a different letter? Let's talk, yeah, fuck it, let's do Y. So we're gonna have absolute value of Y equals some number. I could use 2, but I'm just gonna say A, where A is a real number. So pick your favorite real number and use it. We just saw that if we had a negative inside or a positive version of that same number, we got the result. Like if this was a 2, we saw that -2 or +2 resulted in it. So this means Y can equal A or Y can equal -A. So when we solve absolute value equations, that's how that works. We can look at it as a piecewise function. It equals Y if Y is greater than or equal to 0. It equals -Y if Y is less than 0. This is like the math jargon definition of absolute value. You'll need this stuff, you'll use it in calculus. So it's good to have seen it, but you probably won't remember it by then. And the teacher will bring that up. We already know if we stick in a positive number, this is called a piecewise function. The answer is in pieces. You got two different regions. So if like y is 2, y is greater than 0, and it just spits out positive 2. If y is equals 2, we're on the top line. Because y is greater than or equals 0, so we just get y equals 2. If y is negative 2, we are in the bottom line. Y is less than 0. So the absolute value of y is the absolute value of negative 2. And using this thing is negative y, or negative 2. Because this is y. That's negative y. And two negatives cancel to make a positive. So this equals 2. That's why they say it. Like I said, you're not going to really remember that till later. But it's good to bring it up. That shit's boring. Let's do some algebra. Now, when we have the absolute values alone, this premise applies, but you probably won't think of this when it does. As long as the absolute values are alone, we're going to have one region where the number equals the thing on the right. This forks into two solutions. X plus 3 equals 7. And x plus 3 equals negative 7. So drop absolute value and make one positive, one negative. Now we finish solving. Subtract 3 and I get x equals 4. Or subtract 3 and I get x equals negative 10. Now the computer might want you to write this in solution set notation. They write it like this, which means negative 10 over 4 are solutions. I'm not a big fan of solution set notation. I'm not a big fan of some of the interval notations. Because it looks like plotting points when you have parentheses. Can I check to see if these are true? Let's plug them in. Go back to the top and plug them in. Is the absolute value of 4 plus 3, does that equal 7? Yeah, I get 7 equals 7. What about negative 10 plus 3 absolute value? Once I do that, that's negative 7 on inside, but that it does equal positive 7, so that one works as well. They both work. So in algebra, you can check your work a lot. Ready for some more?
Yes.
gonna do some variance here where there's issues. 4x minus 4, the absolute value, minus 2 equals -2. Before the plus minus thing as the answer, you have to get the absolute value by itself. Must be alone. So I would add 2 to both sides here. If we split this into 2, I have 4x minus 4 equals 0, or 4x minus 4 equals -0. Well, that might be a thought, but what is -0? Like, does 0 have a value? No, so like applying a negative to it doesn't really mean anything. 0 and -0, 0 is the same thing as -0. So these are just actually, there's only one equation. This only one that happens when the absolute value equals 0. Gets down to 1. And here you solve it normally. And we get x equals 1. The other area where the regular equations have something like something to think about is, let's see. Now you might be inclined to do what we did before. Say 2x plus 1 equals -3, and, or not, sorry, and, or 2x plus 1 equals +3. If you go through, you can find solutions, but if you check them, neither of them will work. Why, Davis? You have the questioning look on your face already.
Because we have a negative on the side of the tail. So
We have a negative over here. We have a distance over here. Is distance ever negative? I mean, is school ever -5 miles away? No, distance is always greater than or equal to 0. So you've got something that's either positive or 0 equal to a negative, which is false. That's not true anywhere. There's no solution that works. So if you do this, it's a good idea to check your solutions. And you will catch it. If you don't check your solutions, you won't catch it. So I'll just check one of these right now. If I subtract 1, I got 2x equals -4. I get x equals -2. If I stick in -2, I have -4 plus 1 inside the absolute value, which equals absolute value of -3, which is +3. Which doesn't equal the right side. So it didn't work. I got an answer, but it didn't work.
So to fix that, we would have to multiply by -1 on both sides outside the absolute value.
There is no fixing this. Because if you did that, you still have the same thing. And you still need the absolute value alone, so you need to get rid of the negative sign to solve it. There is no fixing this, there's no solution to this. Okay, so inequality symbols. I think I'm gonna try to spend a few minutes on this on Thursday. Took a little bit longer than I thought. So the inequality with absolute value. Absolute value of t minus 98.6 is less than 2. I'm just going with an example and you'll see where this goes. Now, if I change this to say 98.6 degrees Fahrenheit and 2 degrees Fahrenheit, this is an equation for healthy temperatures, healthy human temperatures. This data together. We do the same thing. For one of them, we keep the value the same with the same symbol. But when you make one of them negative, you have to flip the inequality there. So flip on the one that switches to a negative. And less than, when you have a less than, the less than one turns into an and. And sounds like than, less than. So if I solve these, if I add 98.6 to both sides here, I have t is less than 100.6. And if I add 98.6 here, I have t is greater than 96.6. T less than 100.6 is like that. T greater than 96.6 is like that. And we're looking for the overlap for the and. So 96.6 is less than t, which is less than 100.6. Or in interval notation, not negative 96, positive 96. This is like saying if you're within 2 degrees of your baseline temperature, you're probably not sick. The average baseline temperature is 98.6 degrees. Some people consistently run hotter, some people consistently run colder, but very rarely by a lot. You don't generally have someone with a baseline of 101. That's about crazy talk. So when you're doing absolute value of AX plus B is less than C, do the sandwich. In fact, when you set it up, you can flat out set this initial thing up as t minus 98.6 was less than +2 or greater than -2. Notice if I cover up the middle, this is still true. -2 is less than 2. Always check that when you try to set up a sandwich. Now, when you solve the sandwich, what we used to do equally to both sides now has to be done equally to all areas. So if I add 98.6 here, I need to add 98.6 over here, and I need to add 98.6 over here. So this is another way of doing the absolute value sign when it's less than. And we still get 96.6 is less than t, which is less than 100.6, which is what we saw when we graphed it, did the overlap, and combined them. But again, if you're gonna try to jump straight to a sandwich, it's always a good idea to cover up the shit in the middle and go, is this true? If I didn't have this here, is the outside numbers still have the same relationship? We will do more of this on Thursday, but just for your sake of mind, x plus b greater than c. This turns into an or scenario. So no sandwich. Ax plus b is greater than c, or ax plus b is less than -c. We still, when we've got to flip the sign, when we do the negative, flip. But now it's an or, and you're probably gonna have, shit doing this on the graph. It's probably gonna be a union thing. We'll look at a couple more problems of that on Thursday. It's 5 o'clock. Get the fuck out, Godspeed. Tutoring center is still up until 6. And Ainsley is good shit. She knows what she's doing. Ainsley was one of the only students that I've ever had, and it's only happened this semester, and only because she got the other student to help her or go do it with her. Oh, she took calculus with me in fall. However, she's taking calculus 2 right now. Winter break was a month, and she said, I don't want to get out of practice. Can you give me some problems to do over winter break? She wanted math homework during the holidays, so she did stay out of practice. That's what I'm talking about when I say Ainsley's good. Now, she may not have asked that. I might have asked her if she wanted it, because she said she was worried about Scout 2. I said, well, I can give you problems to take. And she said, please.